So this table that we're looking at right here, folks, just quick review. These are your basic angles in quadrant 1. Pi over 4, pi over 6, pi over 3. Here's your 3 basic trig values, and then their reciprocal values. All right, so those are our angles right here. Pi over 6, pi over 4, pi over 3. Okay, now we've done this table before. All right, then over here are your quadrant angles. Okay, so your pi over 2, pi, 3 pi over 2, 2 pi. These are your values at the different quadrants. Okay, so what we're doing today then is you're going to have given an angle, and the angle will either be in degrees or it'll be in radians, and then you've got to figure out what the exact value is. All right, so it all comes down to finding out what's the reference angle. So this is what we spent 2 days doing last week, was finding those reference angles. All right, so first thing is in quadrant, let's take a look at the first example here. We're in degrees, so we can label our quadrants. So 0, 90, 180, 270, and now draw your 135 degree angle. So Paul, what quadrant are we in for 135?
2.
Okay. So we're going to draw our angle in 2. Now remember, when you're doing reference angles, guys, you're always drawing the angle to the x-axis. All right, so we're going to draw our sketch our 135. Okay, then highlight your reference angle. And we want to figure out what's the reference angle that we use for 135. Okay, Hiram? How are we going to get the reference angle for that? Yep. So we got to find the difference between these two numbers here. Okay, so we know our reference angle is 45 degrees. So then you just use your chart and you find, okay, what's the sine of 45? So this problem right here, guys, is the exact same thing as doing the sine of 45, but then you got to put the correct plus or minus on it. So then I go up to my chart here, I find 45 degrees, and I get my sine value. Okay, which is root 2 over 2. Okay, so I got that from my chart. Okay, now I got to decide, is it positive or negative?
Positive.
Okay, how come?
Wait, hold up.
Holding.
Because it's in the upper quadrant.
Which quadrant?
That would be quadrant 2, right?
Mm-hmm, right there. And we know sine is positive. Okay. So all you got to know is once you pull the value out of here, guys, just use remember, all students take calculus. So S is telling us that sine's positive is the only one that's positive in that quadrant. Okay, all right, 600 degrees. So that angle's bigger than 360. So we gotta find a coterminal angle between 0 and 360. Okay. All right, this is what we worked on last week then. Okay, Sierra, how do we take 600 and get it into an angle that is between 0 and 360? Right. So I'm going to take 600 and I'm going to keep subtracting 360 until I get an angle that's between 0 and 360. All right, so this would equal 240. Now, that's our this is coterminal. So just so that we make sure we get our vocabulary right here. These both end at the same place. So when I graph a 240 degree angle, it's the same as graphing a 600 degree angle. All right. So Cynthia, what quadrant are we going to be in? Yep, so I'm just going to sketch a line. It doesn't have to be accurate. We're just as long as it's in quadrant 3. Okay, label that 240. And then shade in my reference angle. Remember, it's always between the terminal side and the x-axis, never the y-axis. Okay, Trey, what's my reference angle on this?
240 - 180.
Yep. So finding the cosine of 600 is the same thing as finding the cosine of 60. Just got to get your sign correct, if it's positive or negative. All right, so in this quadrant, Ben, is cosine going to be positive or negative? Oh, I'm sorry. Trey.
Maybe negative.
Correct. Very good. And then I just go up, pull that value out of my chart or off of my unit circle, doesn't matter. Okay, there's 240. And the cosine at pi, let's see, 60 degrees. My cosine value is 1/2. And again, if you did it on your calculator, you'd get 0.5 if we just typed in cosine of 60.
So is that final number, the 1/2, that's in degrees or radians?
Okay, so this is in degrees. So the value that's in degrees or radians is the measurement of the angle. So this value is either going to be degrees, in this case it's degrees, or it's going to be in radians. Okay, this value is the x-coordinate. So this is not degrees or radians. Okay, all that means is if I had a unit circle here, let's see, on a unit circle, let's see where I can draw this here. If I had a unit circle, or any circle, doesn't matter. Okay, this 1/2 means, or negative 1/2, if this was 1, negative 1 on the x-coordinate, and this was 1 on the x-axis, negative 1/2 would be located right there. Okay, that's x equals negative 1/2. So there's two angles that have that coordinate. That angle right there, which is in quadrant 2, and the angle we just did, which is right there. Okay, so this is, and when you get this answer part right here, Josue, that's actually, that's a coordinate. Okay, just like, 2, 1 or anything like that, this is a coordinate. So this is not in degrees or radians. The size of the angle's in the degrees or the radians. Okay, now ready. Okay, so let's go on to number 3 here. And why am I frozen? There we go. Okay, 225, find the tangent. Okay. Okay, Marcus, where are we? 225.
In the third.
Okay, reference angle in the third quadrant. Johnny?
45.
Yep. And how'd you get that?
225 minus 40.
Yep. Okay, so there's our reference angle. So doing this is the same, doing the tangent of 225 is the same as doing the tangent of 45. We just got to get the signs correct. All right, tangent in the third quadrant. Miguel, what is it? Positive or negative? Yep. So I know this is positive value, and then I just go to my chart and I pull that value off. Tangent of 45 degrees is 1. All right, now the last 3 guys are simply the reciprocal values. So when I'm doing the cosecant of 300, in order to find, I'm going to first take that angle, change it into something that's between 0 and 360, which it already is. All right, so we'll do that. There's 300 degrees. Okay, shade my reference. Okay, calculate my reference. What do we got, Chris? Mm-hmm. Okay, now on this chart, we've got on our, this would be the same as the cosecant of 60, and now you just check, get your sign, whether it's plus or minus, and then we're going to look this up on our chart. Okay, so cosecant of 60, so here's 60 degrees, and there's our cosecant, which is the reciprocal of our sine. These. Okay, positive or negative? Anthony.
Yes, sir.
Cosecant. We're in quadrant 4. Is cosecant positive or negative? So which one of these is it associated with? Cosecant. Okay, which one of these three functions is it the reciprocal of? Is the cosecant associated with cosine, with sine, or with tangent?
Sine?
Yep. So whatever the sine is on the sine function, cosecant is going to have the same sign because these two are reciprocals of each other. So if one's negative, the other's negative. If one's positive, the other's positive. Right? So by looking at that, we can tell that cosecant in quadrant 4 is going to be a negative value. So you just look at what it's associated with. All right, so we get a negative. So we know this thing is going to be negative. And what do we have? Root 3, 2 root 3 over 3. Now, if you did that on your calculator, guys, you're going to get the decimal equivalent of that. All right, let's see. Secant 240. Okay, so you guys go ahead and do these two. Secant of 240 and cotangent 330. And let's see how we did. Two, and then this one was the cotangent of 30, which was root 3, and cotangent in quadrant 4 is negative. All right, so that's the degree part. And finding reference angles in degrees is pretty straightforward. Finding them in radians was a little bit more involved. Okay. All right, now you're doing the same thing, guys, except your angles are now in radians. So we got to figure out what are the reference angles for those. Okay, so we're dealing with pi over 4. So we had to divide our quadrants up. So I'll do the first one. We've done this a ton of times. Okay, so we're talking about 4s. So if this is 0, then halfway around the circle, pi is the same as 4 pi over 4. And then a full rotation around the circle would be 8 pi over 4. So this was 0, and then this was 8 pi over 4. All right, then we had to find our other two quadrants. So I'm going to look for halfway between 0 and 4 pi, 2 pi. And then I can see how I'm counting. I'm counting from 0 to 2 pi. So if I add another 2 pi, I get 4 pi. And if I add another 2 pi over 4, I get 6 pi. And if I add another 2 pi over 4, whoops, I get my 8 pi. So each time I'm counting by 2 pi over 4 is what I'm counting by. And again, we've done dozens of these. All right, so we've got to take 13 pi over 4 and change it so that it's on this circle. All All right, and we got to figure out what quadrant is it in. All right, so if you remember, 13 pi over 4, we've got to subtract 360, but not 360. We use an alias, 8 pi over 4. And that gets us to 6 pi over 4. No, it doesn't. Let's try it again. 5 pi over 4. So that's my reference angle. All right, so Julian, what quadrant would 5 pi over 4 be on this chart, on my circle? Yep. So I'm going to draw my terminal side in quadrant 3. 5 pi over 4. Shade in my reference angle. Okay, and Elijah, what would that reference angle be?
Pi over 4.
Yep. So 13 pi over 4 is exactly the same as drawing pi over 4. So this is the same as the sine of pi over 4, and then I just go up to my chart, find pi over 4, find my sine value. And then put my plus or my minus on it. Okay, so Caitlin, am I positive or negative? Yep. And there's my solution. Sine is negative in quadrant 3. Now guys, we did it algebraically, finding where the reference angle is. If you have your unit circle, you can simply just count and get your value. Let's see, let me show you. Okay, so we were dealing with 5 pi over, or 13 pi over 4. So if we're counting here, that's pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi, 5 pi over 4, 6, 7, 8 pi over 4, and then I just keep going. 9 pi, 10 pi, 11 pi, 12 pi, 13 pi over 4. Okay, which was the same as 5 pi over 4. And there we can see our sine and our cosine value. So you can also count using your unit circle. We did it using arithmetic to get the reference angle. Okay, 11 pi over 3. Okay, Leilani, what's my quadrant's going to be?
11 pi over 3.
Mm-hmm. How am I going to label my circle here?
So 0, and then 3 pi,
Mm-hmm. Okay.
and then
Full circle?
6 pi over 3.
Mm-hmm. Okay, and then our halfways between 0 and 3 pi? Halfway between 0?
Over 5
Yep.
over 3.
Okay. And down here now.
4.5
Yep. All right, so we got to figure out where 11 pi over 3 is. Okay, all right, so Jaime, what am I going to do to do this to get it on that unit circle, or on that circle that we drew? Yep. We're unwrapping this angle. 11 pi over 3, we're unwrapping it. So that gives me 5 pi over 3. So Reagan, what quadrant am I in? At 5 pi over 3. Mm-hmm. Mm-hmm. And Julian, what's the reference angle? How far is it between these two? I'm sorry? Yep. Pull that out of my chart. Cosine pi over 3 is 1/2. Okay, Chris, positive or negative?
Positive.
Okay, positive. Very good. Okay, now guys, we had 11 pi over 3, so I could use this to count. 1 pi over 3, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 pi over 3 is the same as, 5 pi over 3. We just had to go around the circle twice. Okay. All right. Now, negative angles. We still labeled everything the same way. 0. These are in 6s, so 6 pi over 6. Okay, 12 pi over 6. Halfway between 0 and 6, 3 pi. And so I can see I'm counting by 3. Plus 3, plus 3, plus 3, plus 3. All right, now we want to take this negative reference angle. Instead of subtracting 360 to unwrap it, we got to add 360. So we're adding an alias for 360, which is 12 pi over 6. So there's my reference angle. Now, if we used this and just counted, negative angles are going clockwise. So this is 1 pi over 6, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, where did I miss one? 1, 2, 3, 4, 5, 6. No, see, these are 30. This is pi. This size slice, I'm counting. It's like I cut the pizza, the bottom half of the pizza into 6 slices, and the top half of the pizza into 6 slices. So when I go 11 slices this way, I got 11 slices in there of pi over 6. One, 2, 3, 4, 5, 6, 7, 8, 9. Did I miss one? 1, 2, 3, 4, 5. Oh yeah, duh. Yeah, I didn't count the first one. So that would put me at 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 slices. Okay. All right, and then this one's pretty easy because it's first quadrant, so we don't have to worry about any subtracting. There's our reference angle. And pi over 6 for sine is root 3 over 2. All right. So here, try one just counting. Negative 11 pi over 2, counting, and see where you end up. So this is 2 pi over 2, 3 pi over 2, 4 pi over 2, and we want, that's theta, and we want to get our reference angle. Okay, so try it with counting and see where you end up. Negative 11, so we're counting counterclockwise. Or clockwise, excuse me. So we're going this way, and that's how big our slices are. So we got to count 11 of those. Okay, so where do you end up when you count 11 of those slices? Okay, Sarah. Okay, we're in the first quadrant. Yep, so we end up right there. Okay, so we counted 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and that's the same as what we've been doing, guys, with the arithmetic here. 11 pi over 2. Every time we go around the whole circle, that's 4 pi over 2. So that's, if we drew that angle and then unwrapped it, until we ended up with a positive angle, we end up with pi over 2. I could unwrap it 3 times. Whoops, pi over 2. All right, and then sine at pi over 2. Pi over 2, there's your sine value. All right, you do the last two. Secant of 29 pi over 6 and cotangent.